estimating frequencies. Okay, what algorithms do you know? So when I give you a signal, the samples of a signal which contains 3 frequencies, right? What algorithms do you know to find the frequencies? Okay, you can do Fourier transform, you can do solve systems of equations, and you can use the SVD problem, okay, subspace method. Okay, and then there are 2 pictures down there. One has 2 peaks, and the other one has 3 peaks. And I say, okay, I computed the one of the results with the Fourier transform, the other one with the SVD, with the subspace method. Which one, which algorithm did I use for which picture, right? I should know that the SVD has a better resolution, okay? And so like this, right? So it will be, maybe there is also some question with, I could, yeah, because we do not, or what would be also, we could say, so I give you a channel impulse response, a channel, so channel impulse response, and the signal build the convolution of this, compute the convolution using Martin matrix vector multiplication. Okay? So, and then I say that was A, and then I say in B the channel has not changed. Okay, I have the same channel, the channel impulse response is known, and I have received this signal. Tell me the transmitted signal. So if I say it's only two samples of the transmitted signal, and I have, let's say, a channel impulse response of 2 or 3, right? Then you first compute the convolution. In the next step, you have to solve a system of equations, because now but we have only 2 unknowns. And then I say, what was the transmitted signal? Then you have to solve the system of equations. So then I can say, what are the possibilities to use it, to solve it? You can use quadratic composition, or you can use normal equation, or pseudo inverse. So I don't care, you just name the 3, and then I say use one of them to solve it. So of course, if you have a 3×2 matrix, the best thing to solve it would be the normal equation, right? You make x transpose x, and you have a 2×2 problem, and we will choose the numbers that it will be very easy to solve, right? So, and I mean, this is already the, I would say, from computing point of view, the most complex thing you can do, right? Without a closed book and without calculating and so on. So you will end up with a 2×2 problem, and I assume you can solve that one, right? Then we can, of course, say when we now go to the SVD, I mean, I cannot say compute the SVD of this matrix, right? But I can say, okay, we have computed, we have the samples of an antenna array with 5 antennas. I have taken 20 samples at 5 antennas, and the result, I got a matrix X, which is 20×5, and the result of this of the SVD was this matrix U, this matrix sigma, and this matrix V, right? Where I can just give the U and the V by some, not explicitly, just U, V, okay? But I give you the singular values. I can ask how many signal sources, or how many frequencies are in there. I can ask about the noise space, the signal space. just do sampling of the sinusoid, and then you can do, I can ask for the sampling frequency, right? And then I can say reconstruct the signal from these samples using this sampling frequency, this sampling frequency, and then I'll give you a couple of samples and say reconstruct, and you can say, yeah, does it work or does it not work? Okay, so that's more or less how it will look like. Okay. Okay, and then that's it for the course, and yeah, I think you will have tutorial today, next week also some stuff with Ahmed, and so good luck for the exam, and yeah, so see you maybe for some final thesis or whatever. Okay.